Great, thanks everyone for coming to my WP2 presentation. We'll be talking a lot about how to build your own ChatGPT. So I've been thinking a lot about ChatGPT and how it's recently become this really big public phenomenon. Everyone is talking about it, not just computer science researchers. And I think that the AI technology has already been quite good for a while, and the thing that really made it popular is that its interface is completely different now. It's so much easier now to interact with these AI language models, and that's part of why everything is so exciting. That's why everyone is talking about it right now. So I was inspired to try to build my own. So this is a little video of something that I made. The back end is GPT-3. It's the only OpenAI model that can be fine-tuned at the moment. And just for fun, I made it take on a persona. So this guy is a wizard, and I'm talking to GPT-3, who's pretending to be a wizard. GPT-3 is telling me about how it can cast some spells for me, it can make me invisible, and I'm asking, how do you make me invisible? And GPT-3 just says, I'm a wizard, I can do anything. So it's a bit of fun, and you can do all sorts of personas whenever you want. So the tutorial is kind of divided into two main sections. The first section is going to be an overview of GPT-3, very practical, hands-on, what you can do with it. The next part, which is the main part, we'll focus a lot more on this part, is a design critique. So we'll learn some foundational principles of HCI and then go into the thing that I made and basically complain about it. Throughout the presentation, we'll also see a bit of coding examples here and there, but we won't focus too much on the code. You can go straight to my code base or the fine-tuning notebook online if you're curious and run it yourself and do whatever you want. So as I said, GPT-3 is the brain of our chatbot. When we're talking with our chatbot, it's GPT-3 on the back end. We're sending prompts, and GPT-3 is sending us a completion. So the way this works is that on the back end, we are actually querying this model called GPT-3. It comes from OpenAI, and you give it a prompt as an input, and GPT-3 gives you a completion as an output. There are kind of two main paradigms for doing this kind of thing. One way is called zero-shot prompting. You just give it an instruction. So I'm saying, hey, I want you to pretend to be some kind of persona. The persona is a dog. I'm going to say, hi, how are you? And I want you to say something else. GPT-3 just says, I'm good, how are you? Not super dog-like yet. We also have this thing called in-context learning. So that's when you provide examples in the context. So almost the same example that I just showed you, except this time I'm giving GPT-3 an example of what I wanted to say. So GPT-3 says, I'm excited, more dog-like, I hope. And when I say, what do you like to do for fun? GPT-3 learns to be very excited and says, I love to play fetch, very dog-like. And we also call this one-shot prompting because there's one shot, so one example. You can do this in as many examples as you want. A lot of people tend to just fill up the context window with as many examples as they can. So I give it a whole bunch of examples of how I want GPT-3 to talk as a dog. I'm trying to tell GPT-3 that I want you to be more curious. So in my examples, I say, I love to play fetch. How about you? My favorite food is chicken. What about you? I love going on walks. What about you? And when I ask GPT-3 again, I like walking. What are you doing today? GPT-3 figured out that it should say, I'm going for a walk. What about you? So kind of a silly example, but I'm teaching GPT-3 how to be more curious about me through these examples. We also call this few-shot prompting because there's more than one shot in the prompt. So then if prompting doesn't quite do the job for you, maybe your completions aren't looking exactly as you want them, you can fine-tune. So what you do in fine-tuning is you give a model the prompt and the completion all at once, and then you have it train on these examples. And in this case, the parameters of the model will actually be updated, unlike in prompting, which is more of a conditional generation. So one way I do this for my model is actually to use this data set called Learning in Interactive Games with Humans and Text Dataset, LIGHT for short. And this data set contains a lot of examples of conversations between characters in a video game. So in this example, we actually have a conversation between a mouse and a knight. and the mouse is asking, can you spare some cheese? And the knight is basically saying, it would be my great honor to spare some cheese, woohoo. I do this over and over and over again for a bunch of examples, and that is actually the model that we're playing with in this chatbot. And a little bit of a technical detail, but the interesting thing about this way of fine-tuning is that I have these little, like, hidden new lines. You don't exactly see them, but when I am querying GPT, I'm saying, I want you to write until the next new line. So we're essentially teaching GPT-3 how to, this is basically a bunch of examples of how to talk as a mouse or a knight, all in one example. And then the next time, like maybe I want a wizard, GPT-3 will say something, generate the new line, and then stop. So that's called a stop token. And when I fine-tuned this way back in the day on Curie, for about 10,000 examples, it cost about $40. I think the price would be about the same now, maybe a little cheaper. So then you can actually just see the results for yourself. So on the left, we have a wizard persona without fine-tuning, and I'm asking GPT-3, hey, like, what are you doing? And GPT-3 says, I'm casting a spell. I say, what kind of spell? And all of a sudden, we're talking about cake. So I don't really feel like that's very wizard-like. And I'm, trying to see how wizardy this would be. I'm saying why, and GPT-3 is hungry. I guess maybe wizards eat cake now. And I'm asking it to teach me how to cast a spell, and GPT-3, without fine-tuning, is saying, well, first you gather some ingredients. You need sugar, flour, eggs, butter. Then you mix the ingredients together, and bam, you have a cake. And then I'm like, then what? Because I'm trying to give it more chances to act like a wizard, and it just says, you eat the cake. So that was kind of boring. But way on the other side over here is my wizard persona with fine-tuning. So I'm saying, hey, what are you doing? And already the wizard persona is saying, I'm practicing my spells. So that sounds a whole lot more wizard-like. I'm asking for more information. So what kind of spells? And the wizard is talking about their master. I'm asking about a favorite spell. So cool, this wizard seems to really like gold. That feels pretty wizardly. And then I'm asking about like what job you have and how do you cast the spell. It's telling me about a magic wand. So I thought this was a really cool example of how powerful fine-tuning can be. And it didn't even take that many examples. So then if you want to fine-tune something yourself, it's actually not that hard. The first thing you want to do is make a JSON lines file with all of your examples. So this is the same exact thing I just showed you. The prompt is, the following is a conversation between mice and knight. The completion is the same thing I just showed you. The mouse says, can you spare some cheese? The knight says, yes, of course. And then you just do this over and over again in a single file. Then if you want to call the API, it's really easy from the command line. You have to download the API tool, you set up your API key, and then you call fine-tunes create. You give it the name of your fine-tuning data file, and then you just tell it which model you want to do. If that's too hard for you, you can just steal my code, and it's linked in this notebook right here. Okay, so now we know how to work with GPT-3. Now we can talk about, how do we deal with it? How do we work with it? How do we use it? How do we interact with it? So we're talking a lot about human-centered design. So human-centered design is all about putting the user first. It puts the user in the middle of everything. So the first thing we have to think about is, how do I make the interface discoverable? That's all about, how do I figure out what I can do with this device? If you've ever played around with a new application or a new computer or a new phone or something, your first instinct may be to just look at it and say, if I poke around, what can I do? What will this do for me? It's probably not to go right for the instruction manual and read all about it. Then the next thing is making sure that you understand what's going on. So while you're poking around and things are happening, do you understand what's happening? Do you understand what your interface is doing for you and what you can do with it? So we can make all of this a whole lot easier through affordances, signifiers, and feedback. So what is all this stuff? An affordance is a relationship. It describes what a user can do with an interface. So it's no longer this kind of one-way sort of thinking that you may have had before. It's actually really more of a two-way street. I used to think of an affordance as like a feature, as in what can I what can this thing do for me, but it also really depends on what I can do in general. So that's what we mean by an affordance is a relationship between an interface and a user. So then a signifier tells you what affordances are available. So it tells you what you can do with it. So if I have this camera and I'm wondering what I can do with it and what it can do for me, I might take a look and notice that I have these little shutter buttons. Maybe I click on it. And how do I know that anything happened? That's with feedback. So feedback tells you the result of an action that you just did. So imagine you're using a camera and you click it, and how do you know that you successfully took a picture? The flash goes off. Maybe if it's digital, you'll like see a picture on the screen. Maybe if it's a film camera, like a little thing pops out. But either way, these three things, affordances, signifiers, and feedback, are really important for helping people discover and understand what they're using. So here are a few signifiers from my own chatbot. They may feel pretty familiar. So on the far left, this is essentially just a box, and the box has a little bit of text in it. But I think that you may intuitively know that that's a text box, and if you click on it, you can type stuff into it. And over on the right, we have more rectangles, and the rectangles have a few more words in them, but you may intuitively know that these are buttons, and if you click on them, you can do stuff with them. You may feel so familiar with these like little rectangles in text that you're not surprised when the mouse changes when you put it on top of these mysterious rectangles and text. So it actually turns out that conventions are really, really important for usable interfaces. This is something that we can discover through user studies. It's something you can talk about, or just think to yourself, you know, what would I expect something like this to do, or what would I expect something like this to be set up? And violating these conventions actually just leads to like instant frustration. So like the next time something is not working for you, you might think about, is this affordance what I'm expecting? Is there a signifier that's telling me what I can do that makes sense? Or maybe is the feedback I'm getting just not good enough or misleading? So then affordances are all about what you can do with something, and that depends a lot about what you can do. And according to this ability-based design framework that I really like to think about, ability is the possession of the means or skill to do something. So it's very positive. You can't exactly have a disability, you just have more and more abilities to do things. I think it's really interesting to think about this when we're designing interfaces for many people. We can describe abilities in a couple of ways. So first, ability has a source. It goes from being completely internal to being completely external. So maybe someone who is trying to click on something, maybe they can't. Maybe their arms are full. Maybe they don't have arms. So that's an example of something being very internal versus very external, and no matter the context, the ability ends up being the same. Ability also has a duration. So it can be ephemeral, maybe like blinking. Technically you can't see when you're blinking, but it's very, very brief. To long lasting, maybe you're blind, maybe you have low vision. So when you combine ability, like when you think about abilities in this way, I find it really interesting to just understand that when you design for a wider range of abilities, no matter the context, more and more people can use everything in more and more situations. So we talked a lot about the foundations of all of these design principles and everything like that. Now is the time to go into my chatbot, really dig around and see what I did well, what I didn't do so well. And there are some really interesting research-based evaluation principles for doing these kinds of things. So this paper has a bunch of heuristics for conversational agents. So conversational agent is basically any interface that you can have a conversation with. It might be a chatbot, like the thing I made. It might be voice-based, like one of your favorite voice assistants. Maybe it's on your phone. Either way, these are some research-based design principles that are based on some older Nielsen's principles that are very classic in design. And we'll focus on 3. So I think that I did pretty well for consistency and standards. I did okay for context preservation, and I did super terribly for helping users recognize, diagnose, and recover from errors. So when it comes to consistency and standards, this paper by Langevin et al. Recommends that users should not have to wonder whether different words, options, or actions mean the same thing. You should follow platform conventions for the design of visual and interaction elements. Users should also be able to receive consistent responses even if they communicate the same function in multiple ways and modalities. Within the interaction, the system should have a consistent voice, style of language, and personality. So this is a whole lot to take in. The first thing that this particular heuristic recommends is making sure that things are consistent, that things mean the same thing. And a couple of ways I go about this is to use consistent terminology. So I'm saying persona and chatbot. I'm not saying personality and bot or virtual agent or something like that. Try to use the same language across the platform. I'm also showing chatbot messages in one consistent style. So if you remember, those were the gray boxes on the left. And I'm also showing human messages in another consistent style. Those were the purple messages on the right. They also match a whole lot of conventions on iMessage, where your message is blue on the right and the other person's message is gray on the left. I think it also follows from WhatsApp and a whole lot of other different messaging services. Somehow this convention popped up and we're sticking with it, and it helps people understand what's going on really quickly. This is quite easy to do in the code. So this is CSS. CSS helps you apply styles to HTML objects. And all I did was to have one particular thing that applies to bot messages and human messages. That's that on the left. You might notice that every single message has this small gray border. And it's really easy to make that consistent throughout the entire thing with CSS. Then over on the left, we have different ways of applying styles to particular messages. So every bot, like I just said, is going to send a message in gray. The chat bubble is gray. And then every human message is going to be in a purple chat bubble. And then you just apply these as classes throughout your HTML or whatever framework that you like. Then the next part of this consistency and standards is to follow platform conventions for the design of visual and interaction elements. So we just talked about how different types of messages are in a specific style throughout the platform. You haven't had a chance to use my thing yet, but there's actually two ways you can actually send a message. You either click the send button or you hit enter on the keyboard. Notice though that there's no signifier for hitting enter on the keyboard. You just might think to do it and it works. Even this is pretty easy to do. This is jQuery, so it really speaks to how hacky I was being while setting this whole thing up. But all you gotta do really is just set up these event listeners for key presses and clicks. So what this does is it listens for when a button on the keyboard is pressed. It checks if the button is the enter key, which is what the 13 means, and then calls the get response function, which is what calls the OpenAI API to talk with the person. The second bit of this code is very, very similar. It's listening for a click. So if the send button is clicked, it's basically going to do the same thing. Finally, within the interaction, the system should have a consistent voice, style of language, and personality. I think this is probably the most challenging part, and I didn't even do much to it. I gave GPT-3 a prompt and hoped for the best. I feel like this is quite an open research question. It's definitely an open problem in more advanced voice assistants like Alexa or Siri. How do you make sure that the thing that's talking to you is gonna talk the way you want it? I think it also just causes a little bit of worry just in the public in general, you know, like trust in language models. I don't have an answer for you because I didn't do anything all that complicated, but I do think it's really worth thinking about how we go in and fix up these models and make sure that we trust that they're going to do what we want. Context preservation. I think I did like okay at this. So context preservation is all about maintaining context preservation regarding the conversation topic intra-session and if possible inter-session. allowing the user to reference past messages for further interaction to support implicit user expectations of conversations. So this is all about making sure that we stay on topic during a conversation, but even better, can the thing remember what you talked about in other conversations? I think that this is still not quite done today. Like, if I talk to Siri, Siri might not remember that I prefer this or that food when I talk to Siri later. So I think that this is a really interesting open research question as well. The way I handle it is to use basically the same prompt every time, but I'm going to pass in the past 2 turns of the conversation every time that I prompt the model. So this means that GPT-3 will forget what I said if it's not within the past 2 terms of the most recent conversation. The way that ChatGPT does this is to just have a huge context window and just kind of work with that every time so it can remember more at a time. Before the age of ChatGPT, I remember seeing work about how do we help models track states in a conversation and disentangle different parts of a conversation, which I think will be very interesting if we don't want to just use a huge context window all the time. It's very memory intensive. I generate this prompt, and then the way that you query OpenAI, I put it right here so you can copy and paste my slides if you want to later, is just stick it in the API call. You just create an API call, and then the text of the call comes right there. And then you can use the response how you want. I just give it. I don't do any sort of like processing or filtering or anything like that. Maybe that's worth doing that a little bit better. So the last bit is helping users recognize, diagnose, and recover from errors. To do this, error messages should be expressed in plain language, no codes, precisely indicate the problem, and constructively suggest the solution. And I don't know if you've ever tried to do error handling in your own code, but I certainly hate doing this. It's very difficult to do because you never know what error may pop up. The way I do it, I do it in this very simple way, where if an error happens to pop up, all I do is just send the OpenAI error message straight on through, and I make the box yellow just in case someone thinks that GPT-3 just wants to talk like an error, and that's really it. Because that was the simplest thing programmatically to do, but it's not always the best thing usably to do. And this is basically all I do to do it. So this is actually JavaScript. What I do is I get the GPT-3 response from my Python backend, and then I stick it inside a message bubble, and then if the message is actually an error, I just change the background color. So as simple as that, that's all I do. But I think that there's a whole lot of better things that I could do. Maybe if I checked what type of error it was, I could guide the user in different ways. So the error that I just showed you came up because I actually disconnected my computer from the Wi-Fi and forced it to give me an error so I can show you what happens. And maybe I could say, the OpenAI API is not responding, maybe your Wi-Fi is broken. Another error that I've seen pop up a lot is something like, the model is being loaded, try again later, which completely mystified me at first because I don't really know what that means. And it turns out that sometimes when you're not using a fine-tuned model for a while, OpenAI will basically kind of cache it or just kind of get rid of it because they want to preserve some memory. And if you're using an old model after a while, it has to call it back and it has to load it again. And that's the error I was running into, but it didn't quite communicate with that to me, so I wasn't really able to recognize what was going on, diagnose the problem, or even recover from it. I did the age-old, okay, I'll just try again later, which is exactly what they wanted me to do, but it was unclear. So I think that there's a whole lot more that we could do. And I also think that the bottom line is that every new interface really has all of these foundations in common. So maybe your interface is something as simple as my thing, maybe it's this kind of not actually very complicated ChatGPT interface. Maybe it's as fancy as Alexa. All of these things is just you interacting with AI in some way with a conversation. So it's really worth thinking about how these things work under the hood, and then how we build on top of them to make everything easier to use. That actually brings me to the end of my presentation. I'm happy to answer questions.